Why'd you yell at him?
Because Matt Dotz knows how to push my buttons.
Dip and dot.
I told her I wanted to be in the front. Dots can switch. Alright. What?
Yo, can we switch Mason and Dots, please?
No.
Alright, then fuck.
Alright, so
You're gonna
Today-
be more privileged, but you don't wanna do
I
that.
just want to be in the front.
Oh my gosh.
today we are going to do section 9.4, and then tomorrow you have practice quiz, and Thursday you have a quiz. Okay?
I won't be here Thursday or tomorrow.
Where are you gonna be?
Here.
Moon class.
Here?
Yeah,
Jordan.
early on Thursday.
Sorry.
Tell me how.
Jordan, you're late again.
Jordan, what's that?
No, you haven't.
Oh my
That's a
gosh.
target.
That's an hour.
I know, but I told you.
Yeah, I'm not a fan of
Let's
that.
move it.
You're too close to these four.
You said that last weekend, it never happened.
Oh, and it's zero gravity.
Look at that.
Oh, man. Let me see.
Bottom of one story.
Up here?
You know, I think you
We
can bring
need
it
you
down.
down.
We have to like separate it. Yeah,
Yeah.
I need my purse, yeah.
How many kills?
You can dump it.
Who's gonna make fun of that?
There's so much work to bring it back here.
That's why.
But the Vikings are ready, but now I've got to hear they're gonna go all that again.
Jordan,
Yeah,
Oh.
I got it all figured out. There's
Yeah, I know.
You spelled your own name.
Right now.
I didn't name myself.
Whoa, Paul.
Did you just call me?
What just happened?
All right. Okay, so you guys should have out your cheat sheet again today.
Bring it up.
Andy, what the hell are you doing, man?
Gotta
You
be
are
careful with the
banned
chair.
from touching that chair, okay?
Simple accident, Doc. It was a simple accident.
That was an honest accident.
All right, so we are going,
This button. Hey, please go in my locker and grab a pencil. I don't like those pencils.
I'll get one for you,
No,
Caleb.
I want to. No.
okay,
I wanna-
Caleb and Owen, we are, what grade now? Sophomore?
Yeah, we're.
Not old enough.
All right, so we are going to move on to the next section. Honestly, I think you're gonna find today that we don't learn a lot of new stuff, okay? A lot of what we are gonna do is things that we've already done. So I don't think you'll find that this is too bad today, okay? So you guys know on the unit circle, if you have a point and then it has an ordered pair, what trig function comes first? Cosine. And then this is sine, correct? So that is what this is talking about, and because I showed you guys the unit circle in the previous problem, or the previous section, that is stuff you already know. So we're just gonna go to this page, and what they have is they're giving you a point on the unit circle, and that point has an ordered pair, and what they're asking you is from this ordered pair, what is the cosine and what is the sine? What would my cosine be?
Half.
A half. And what would the sine be?
The square root of 3 over 2.
Yeah. So I showed you guys the unit circle earlier than I was supposed to, so you guys already know that. So you're good
So this is what we have to do today?
for this part, yes. So if they give you a point here and they ask you for the cosine and the sine, and they give you an ordered pair, the first thing tells us what?
Cosine.
The cosine. So this would be right there. And the sine would be negative 4/5. Is that easy enough?
Yeah.
Okay. All right. So now let's look at this. Next week, we are going to learn how to graph trig functions. And I will be honest with you, graphing trig functions is not easy. Yes. So anyway, if you guys look, what's going to happen when we do these next week, they're called periodic functions. And what a periodic function is, it means that the graph repeats itself as it goes. Okay?
We got school Fridays.
So it says one complete pattern on a graph is called a cycle. So this is a graph, Caleb, please. This is one complete cycle, and then it repeats itself, and then it would repeat itself. So what that one complete cycle is, that is going to have a length that's called a period. It's how far over does that graph go before it repeats itself. So if you guys notice here, it started at 0 degrees and it goes to 360 degrees. So one complete cycle has a period of 360 degrees. So that's another thing when you see graphs next week when we do trig functions. Here, there will be degrees, okay? And a lot of times it'll go from 0 to 360 or 0 to 720 when you're graphing those, okay? So down here, they want us to determine how far is one complete cycle, and that's called a period. So do you guys get that if I start here, doesn't it start to repeat itself right here?
Mhm.
So this is one cycle. So isn't the length of it 4?
Yep.
So your period is just 4. That's all you have to do,
That's crazy.
okay? Now this next one, if I start here, do you guys get that I'd go across, down, over, up, and then I would again go across, down, over, up? So isn't one period from here to here? And how far is that? 2, right? So my period is 2.
So Bob, the period and the cycle is like the same thing, but.
Yeah.
The period is.
The period is the length of the cycle.
Okay.
Okay? Now this actually, you guys, is the sine graph, okay? It starts at 0, goes up to 1, we'll talk about this next week, comes down to 0 at pi. This would be 3 pi over 2, which is 270, and at 2 pi, it's back at 0. So do you get that one complete cycle goes from here to here? So what is the period then? 2 pi. Yep. And we'll talk about that next week. Okay? Now look at this one. It starts here. It goes across, up, down. Do you think it repeats itself here? No. It goes up and down again, and then it goes across again. So do you think it stops right here?
Yes.
Do you get that? 2.5 pi, right? Because this is 2 pi, this is 3 pi, this would be 2.5 pi. And actually, do you guys know how 2.5 is the same thing as 5 over 2? Do you guys know that? Like 2.5 is the same as 5 halves. So usually in trig, they would write it as an improper fraction, but I would not mark it wrong in this case if you put 2.5 pi. Okay. Now here, notice they do this upward triangle and then this little curve. And do you think they're starting over again right there?
Yes.
They're going to go up and then this curve. So what is our period? 10. Okay. Then down here, notice they do this big kind of triangle thing, and then they go up, down. Where would they start repeating? At 4, right? And then they would go up, big, small, up, big, small. So what is our period?
4.
here, notice we go, do I have this one on here already? Different, yeah. Okay, notice we go across, up, over, down, across, up. Do I stop there? Right? So my period would be 2 pi.
This is not bad.
All right, so now,
I don't, well, I just looked, it's not bad.
now is when you would normally be introduced to the unit circle, but we did that already. So that's why this section is easier, is because last section I introduced it already. So here's our unit circle, okay? And this here we'll talk about more next week. But this is what this is showing. If you went on your unit circle and you figured out what is the sine at 0 degrees, isn't sine our second one? So do you see how at 0 the sine is 0? That's this point right here, okay? Then at 90 degrees, what is our sine? 1. It's the second thing. That is this point right here, okay? Then at 180 degrees, what's our sine? 0. That's this point right here. Then at 270 down here, what's our sine? -1, right? And that's this point down here. And then when you're back here, this is 360. What's our sine again? 0. So that is a complete sine graph. And that's something you're going to get really good at drawing, because we're going to take those and draw them. We're also going to make changes to them. And then this is the cosine graph. So let's do that same thing, but this time let's look at the cosine graph. Okay? So if we do that, what is the cosine of 0 degrees? 1. So the cosine graph starts up at 1. Notice the sine graph started at 0. Okay? At 90 degrees, what's our cosine? 0. That's this point right here. At 180, what's our cosine? -1. That is this point down here. At 270, what's our cosine? 0, right here. At 360, what's our cosine? 1 again. Do you get that one period of this before it would start repeating is from 0 to 360? So wouldn't the period be 360? Everybody understand that?
Mm-hmm.
Okay, so let's go here. This question is exactly like what I started yesterday. And if you are comfortable with unit circle, and there's times we have to find coterminal angles with these angles that are on the unit circle, okay? Do you guys get 480 degrees is too big for the unit circle? Yep. So how do I get it down to something that's on?
Minus 360.
I go 480 minus 360, which is
120.
120. Now, could I find cosine of 120 on my unit circle?
Yeah.
Okay. 120 is right here. This is the point. Which one of these three is my cosine?
The middle.
The middle, yes. It's that first part of the ordered pair. So wouldn't it be -1/2? That is my answer. Okay. Now, 11 pi over 4, like you kind of have to think about, is 11 pi over 4 between 0 and 2 pi? Okay. Do you guys know what 11/4 is? 11 divided by 4 is what? It's more than 2. 2 3/4. So do you get that this is too big for our unit circle? So if it's too big, what would I do to get it to pare down so it is there?
No solution.
Subtract 2 pi, okay? So Mason is saying you'd really subtract 8 pi over 4, right? And he knows that because you have to get common denominators. And if you put a 4 on the bottom, you have to multiply by 4 on top. So we would get 11 pi over 4 minus 4 times 2 pi is 8 pi over 4. What is 11 pi over 4 minus 8 pi over 4? Wouldn't it be 3 pi over 4? Correct? Now, what is the sine of 3 pi over 4? So we're going to look for 3 pi over 4. It's right here. Here's my point. Here are my things. Which one is sine?
The second one.
In the ordered pair, right? Isn't it root 2 over 2?
Yep.
That would be my answer. Okay.
Where do you see this?
Now, for your unit circle, if you use the cheat sheet, it's a lot easier to see your unit circle. Okay? Can you guys tell when this one's negative, automatically we have to move it to a different angle? And if it's negative, what would I have to do with it? Would I subtract 2 pi or would I add 2 pi? I'd add 2 pi. And you know when you add 2 pi, don't you have to get it over 6? And if I do that, I'd multiply the top by 6 also, correct? Now I get negative 5 pi over 6 plus 6 times 2 pi is 12 pi over 6. Okay. And then when we go to simplify that, what's negative 5 pi over 6 plus 12 pi over 6?
7 pi.
Yep, it's 7 pi over 6. So we have to find the cosine of 7 pi over 6. So if I look on my unit circle, 7 pi over 6 is here. Here's my point. Here's the tangent. And which one of these is cosine? You sure?
Negative. I don't know. I can't
It's negative.
Yep, negative root 3 over 2. Okay, negative root 3 over 2 is my cosine. Now the next one is asking us to deal with a 540-degree angle. How would I get that so it's on my unit circle? I would minus 360. What's 540 minus 360? I think it is 180. Okay. What is the cosine of 180? Cosine of 180
Negative.
is right here, and isn't it the first one, which is negative 1?
Mhm.
Okay. Then we have sine of negative 390. If it's negative 390, what would I do first? Add 360. And is that still going to be negative?
Yep.
It's going to be negative 30. So what could I do again?
And 360.
Add 360. And what's negative 30 plus 360?
330.
330. What is the sine of 330?
Wait a minute.
So if I go over here, here's 330, here's my dot, here's these. Sine is negative a half. We get that? This is cosine, this is sine, this is tangent. So it's going to be negative 1 over 2. Now we have sine of 4 pi. Is 4 pi too big for this?
Yeah.
So what would I have to do with that? Minus 2 pi. And 4 pi minus 2 pi is 2 pi. Now, do you guys get really over here is 2 pi? So couldn't I use these to do this one? Because 2 pi is on there. So what's sine of 2 pi? Sine is going to be the second one in the ordered pair, which is 0. So is that okay? All right, now let's go to this last page. This is doing exactly what we were doing, except we're kind of evaluating different expressions with what we find off the unit circle. So sine of 45, I can find on my unit circle. And like I said, I would always have your cheat sheet out with your unit circle. Sine of 45, here's 45. Here is your values for sine of 45. Isn't sine the second one in the ordered pair? So it'd be root 2 over 2 minus sine of 30. Here's 30. Here's my values for 30. Which one of these is my sine? 1/2. Good. So when I go to add or subtract fractions, they have to have the same denominator. And these do already, correct? So that means I can combine them, and on the bottom I'd have root 2. Can I combine root 2 and 1? No. So what you would do then is just write that as the square root of 2 minus 1 on top. And there's nothing you can do with that. You can't combine it anymore, and it is okay to have a square root on top. Okay, so that's my answer. Now if I come to this one, it's 6 times cosine 30. So here's 30 again. Here are the values. Which one of these is cosine? This one, root 3 over 2, correct? Root 3 over 2. Now we're going to multiply that by cosine of 60. Here's 60. Here's the values. Which one of these is cosine? 1/2. Okay. And I think what I'm going to do is just like multiply across the top and multiply across the bottom. So on the top, do you guys get, you would just get 6 root 3 times 1 is just 6 root 3. And then if you multiply on the bottom, 2 times 2 is 4. Now you can never simplify this, but you can always simplify this as a fraction. Is there a number that goes into both 6 and 4?
2.
2. So do you get that 2 goes into 6 3 times? The root 3 I keep the same, and 2 goes into 4 twice. This is my answer. Do you understand that? Okay. Now let's look at this next one. It says cosine of 45. Here's cosine. Here are the values. Which one is cosine? The first one. And what do they want us to do with that? It's root 2 over 2. And don't they want me to square it? Right? Then we have sine of 45. Sine of 45 is right here. And that is root 2 over 2. And that is squared. Okay? Now, root 2 over 2 squared. What do I get when I square a square root? 2. And what's 2 squared?
4.
4. Okay. Root 2 squared is again 2. 2 squared is 4. There's 2 ways you can do this. Do you guys get this is 1/2 plus 1/2? And 1/2 plus 1/2 is 1. If you had kept it like this, do you guys get it would have been 2 fourths plus 2 fourths is 4 fourths? Is that also 1? Yes. Okay. Now this last one, we have 2 times sine of 4 pi over 3. So 4 pi over 3 is right here. 4 pi over 3. The point is right here, and these are our values, okay? And these are hard to read, but if you have your cheat sheet, or your cheat sheet should have that on there bigger. So sine of 4 pi over 3 is going to be the second one, and it's negative root 3 over 2. So we have 2 times negative root 3 over 2 minus 4 times, and it's sine of 2 pi over 3. 2 pi over 3 is right here. Here's my point, here's my values. Which one of these is sine? The last one in the order pair, which is root 3 over 2. Okay. Now, what do you guys think would happen to my 2's here? Wouldn't they cancel? And I would get minus root 3, subtract. Now, could I reduce the 2 and the 4? 2 goes into 4 how many times? Twice. So do you guys get, I could cross this out and make this a 2. And wouldn't I have minus 2 root 3? Now, think of this like if it was negative x minus 2x. So think of those root 3's as if they were x. Wouldn't this be like negative 1x minus 2x, which is negative 3x, okay? So think of those as just anything that you would combine, okay? So this is like negative 1 root 3 minus 2 root 3. So you're going to get a root 3. What's negative 1 root 3 minus 2 root 3? Yep, negative 3 root 3. So do you see how this is really the same as this, except where my x's are, I have root 3's. And when I go to combine those, I just think what's negative 1 minus 2, and that's negative 3, and I keep that root 3. So this is my answer. Okay? So your assignment for tomorrow is this.
Oh my God.
Because our janitors are short, so if by the time you leave, if you guys could pick up any paper on the floor around you. We have one janitor out sick and one janitor quit. So we're down 2 janitors. So they're kind of over.
Our superintendent quit too.
Yeah, he's sick of
He's sick of it.